on deck.
Go! I use the same, like...
Okay, so now we're starting.
Do I share this or not?
Yeah. So hello everybody.
Hi.
Hello.
Our presentation is on maps and vectors.
Your presentation?
Our?
You mean our?
Shut up. So, first of all, vectors, they're like arrays. They are a collection. However, a vector is more fluid than an array because there's no need to set a cap before defining the array, which meaning the vector can increase and decrease its capacity as you put in or take out stuff. So, vector class in Java implements a growable array of objects. Like an array, it contains components that can be accessed using an integer index, 0, 1, 2, 3, 4, 5. However, the size of the vector can grow or shrink needed to accommodate adding or removing items after the vector is created. So how, if you do an array and you set it to 10, well, it's going to be 10. You can't put the 11th object in it. But for vectors, you can continue to fit more things and it will stretch. So how to use the vector? How to use the vector class? First of all, you have to import the class at the top of your program. And then there's a couple ways of declaring the object, the vector class. You can just declare the default vector, which will set the default size to 10, but that doesn't matter because it can expand. Or you can specify the size when you're declaring the vector by just putting it in the bottom there. Or you can create a vector from other collection types, which are, so collection is short for Java Collections Framework. It's a set of classes and interfaces that implement commonly reusable collection data structures. And although it's referred to as a framework, it works in the manner of like a library. So the Java Collections Framework provides both interfaces that define various collections and classes that implement them. There are 3 generic types of the collection. There are ordered lists, dictionaries and maps, which Tom will get into, and sets. And then finally, these are some of the common vector methods. First of all, you have copy into, which copies the components of this vector into the specified array. And the item at k index and this vector is copied into component k of the array and returns the current capacity of this vector. And then capacity returns just the current capacity of the vector. Trim to size, well, according to the name, it trims the size. So, so if the current capacity of this vector is less
Did you get that on video?
Yeah.
than the minimum capacity, then its capacity increased by replacing the internal data array, which kept at the field element data, with the larger one. The size of the new data array will be the old size unless the value of the capacity and increment is less than the capacity, which will be twice the old capacity, so it's kind of complicated. And finally we have ensure capacity, which is what I just talked about.
Alright. So what B was saying with collections, a collection is a type of interface. Another type of interface is what I'm going to talk about are maps. There are many different types of maps. There are hash maps I'll talk about, sorted maps, and I'll talk about hash tables, which are down here. Tree maps are a part of sorted maps, but for the maps I'm going to talk about, and pretty much all the maps besides a tree map, there's what they call a key and value, which I'll get to later. For binary trees, like what Kofi did, they use nodes. So this is just a more elaborate diagram of all the different types of maps. So again, maps is the type of interface, and everything stems down from here. Hash tables are located over here on one side, and hash maps are located here on the exact opposite. That's because a hash map is a type of abstract map, which uses the key and value, but for every key there could be more than one value. For the hash table, it's just a 1-to-1 ratio.
More on that later.
Yeah, more on that later. Again, it's the dictionary interface, what Erica and Igor did yesterday. So again, it's that 1-to-1 ratio for every one key to one value. and when keys and values come together, it makes an object. Okay, so first off, I'm going to start about sorted maps. Sorted maps use primarily numbers. I try to find instances where instead of numbers, it's letters, and it alphabetizes letters, but from what I found, it's only numbers. So you have an array of numbers, unorganized, and it splits it down the line. So you have eight objects, splits it into 4 groups. You have 4, he splits it down to 2, and it always gets 2 sets of 2, and looks at 2. 54 and 13, well 13 is smaller than 54, so I switch it around, and it comes out with the new block 1354. And that block goes back to the, looks back to the first block of 4, and then takes the other block, or other 2 unused blocks, breaks that 24 and 19, well 19's smaller than 24, so it switches that, so it makes a new block 1354, 1924. So then it looks at that again. Okay, 54 and 19 are, or 19 is smaller than 54, so it switches that, so it reads out 13, 19, 54, 24. Well, we see 24 and 54, 24 is smaller than 54, so it switches that. So the output is 13, 19, 24, 54 in ascending order. And it was, so that's only for the first part, first set of 4 for the array of 8. It does the same for the other side, so instead of just explaining all that again, apply these numbers into what was shown here. And again, prints out numbers in ascending order. Usually, it's only used with arrays instead of individual integers, so I also found that. Probably one of the most common examples of this is in Excel. If you have a set of numbers in different cells, you highlight the cells, you can, I think it's the data tab, and then sort ascend is how you print out numbers in ascending order. So now to hash maps and hash tables. This is the most basic form of presenting keys and values. I know it's not a
Wait,
number,
was
so.
that actual number?
No, I just made
no.
a 610 was the Pottstown area code, and then I just increased 100, 1, 2, 3, 4, 600, 110, 1, 2, 3, 5, and just added 1.
I'm gonna ring you into it.
Please don't. That's a calculator.
So this can both be a hash map and a hash table, but really this is a hash. This is actually a hash table because it's only a 1-to-1 ratio. If we wanted to do, say like we did with mate, and we wanted to put each person's jobs on there, then it would become a hash map because it's 1 key for 2 values. Again, when keys and values come together, they form an object. So if you have like a phone book of everyone in the world, which is a large assortment of data, you can just type in the key and it prints out the value, but you cannot go reverse. You cannot input a value and it returns the key. You need to put in the key first to return the value. So here. So here's just a little video I'd like to show. I'm probably not going to play the whole thing. I'll start it just to get this error out of the way. But
Hi, this video tutorial.
sorry, Matthew. So it explains the differences between a hash map and a hash table. So some of the words in bold were I looked up. So does anyone know what synchronized and unsynchronized means?
I'm guessing at the same time and not at the same time.
Yeah. So a hash synchronized means that a method cannot be executed by 2 threads or 2 values at the same time. It's that 1-to-1 ratio. And then a thread is either an object, a variable, or type an array. What about a fail-fast system? Anyone know what a fail-fast?
A system that fails fast.
Yes.
Wow, you're so smart.
So,
What was that?
when a problem occurs in your code, and we see that, see this in Eclipse, a fail-fast system fails immediately. It won't even run the code sometimes, depending with just a fail system where it'll try to work it out, but if it can't, it'll be like 50% through the project and it would just stop. So then thread safe works correctly when many threads are using the same resource, so many values are pointing towards one key. The enumerator is a type of interface that generates a series of elements, so that's here again with the hash table, it's the one-to-one. Again with the dictionary class, it's one-to-one. And that's it.
Cool.
So yeah.
So